Exactly 1 year ago, we had one mission: to build an electric racing motorcycle.
And after many weeks of designing and building, now we're ready to race.
We did a lot of research on geometry of a motorcycle. Geometry is one of the most important things to be able to ride the motorcycle good. There's a sweet spot. If you get out of it, then the motorcycle can be uncontrollable. You have to consider pivot locations, angles, distances, but also suspension and center of mass. For some of these, we looked at common motorcycles. For others, they are case specific and they need to be calculated. On a motorcycle, space is a luxury, so you have to use it efficiently and carefully think where to place your components. The batteries are the biggest, but you need a lot of them. So we built the motorcycle around the batteries, and we made a modular and square-shaped design of the batteries, which is also fairly easy to build. In order to achieve this, we moved the electromotor to the back and somewhat integrated it with the frame and swing arm, which also promotes structural stiffness. This is the key to our design.
So this is the design of the bike. The aesthetics were quite important, and we wanted to make a design that it's not only technically advanced, but also that looks really cool, because we want to promote electric mobility. We first had to get a common vision with the team. And from there on we started sketching and we made a 3D design. And as you can see, it has quite some sharp lines and also a bit organic. And it has quite some unique elements in the design, but you will see that later on. Making the design was quite hard, but I think we succeeded.
We decided to mill the entire bike out of blocks of foam to get our real physical shape from the bike. We worked with the entire team upon finishing these molds, coating, sanding and polishing these molds on which we could make our bodywork. We used fiberglass, aramid fibers and polyester resin as building materials for our bodywork. And this results in a very strong but also light and tough material, which is easy to form in our desired shape. In the end, we totally underestimated the amount of work that went into the building of the bodywork, but that also tempted us to go for more complicated and futuristic design, which really stands out from the crowd in my opinion. I also worked on the design of the frame itself. We started with a lot of ideas, about 30 ideas, and we ended up with this kind of trellis style kind of frame. In frame design, it's important to get the stiffnesses right, because the motorcycle frame needs to act as a suspension during cornering to get good grip from the tires. We also had no engine inside our frame to work with, so we needed to make the frame a little bit stiffer to keep up with the rest of the world.
And together with the main frame, the swing arm is responsible for the total stiffness of the motorcycle. Therefore, it should be designed to provide the best driving characteristics in the world. We did both the design and the production of the parts ourselves, and we had some help with an expert welder. When you combine that with one of the strongest aluminum alloys in the world, you really result in a light, durable and strong swing arm.
For the cooling system, we had 3 components which had to be cooled: the electric motor, inverter and the battery cells. For the electric motor and both the inverter we used water to cool them, in combination with 2 little radiators on the bottom of the motorcycle. And for the battery cells we used the forced induction from the driving wind to cool them.
So in the center of the motorcycle there's the battery pack. The battery pack consists of 1,500 lithium-ion batteries, and these have a combined voltage of 700 volts and a maximum current of 250 amps. This makes it possible for the motor to deliver the 200 horsepower, and in the end we were very happy with the fact that we fulfilled all the design requirements we had in the beginning. Together with our sponsor AE Group, we designed a custom electrical motor which fitted exactly our requirements. With this came the fact that we had to make our own housing, which was also an advantage for us, because then we could make it exactly how we wanted to and have the dimensions we wanted to have. But there also were quite a lot of design challenges, but once we overcame these design challenges, in the end we were very happy with the result we got.
The electronic control unit, also known as the Superbike control unit, is considered to be the most important part of our motorcycle. It's like the human brain. Without it, it becomes almost impossible to monitor the behavior of our bike. And this is important for us because we want to improve our bike next year. We've also looked at other alternatives, but they had sufficient drawbacks. They were either very costly or very heavy. That's why we decided to make our own. The result is an ECU that has a lot of digital interfaces, a lot of analog inputs. It has several communication interfaces, and last but not least, it's less expensive and it's very lightweight.
We developed our battery management system together at ProDrive Technologies in Eindhoven. We did so since the battery manager is extremely important. It measures and controls the output of the battery pack.
The battery management system contains 3 parts. First, the 10 satellite boards, which measures temperature and voltage of all the cells in the battery pack. The output of the battery pack goes through the high voltage board to the rest of the motor and can switch it on and off. And the control board collects all the data. That's how we keep our battery in excellent condition.
We're using an AIM dash logger to log all our data from our sensors on the bike, from brake pressure to battery temperature. And after the race we can read all this data out to see if there's something wrong with one of our components or with one of our sensors. But the most important part about an AIM dash logger is that we can show all this data immediately to the driver. And the most important information for a driver is our sector times. We can show him his sector times relative to his previous sector times. This is the motor controller. Without the motor controller, the motor cannot rotate. We decided to buy this part because it's a crucial part of the bike, and it's also very difficult to develop such complicated software within a year. However, we are planning to make our own motor controller in the near future. Due to the inner workings of the motor controller, it's very important that the motor controller doesn't get too hot. That's why the motor controller is water-cooled.
In a year like this, you experience what it is to be part of a student team. We work closely together to achieve our goal. You not only the technical aspects, but also the non-technical aspects, such as managing the team, acquisition and marketing. For example, I study mechanical engineering, but I do the financials for the team. I joined Electric Superbike Twente because I find it a really awesome and challenging project. That's why I'm currently busy with my motorcycle license. So one day I will be able to drive an electric motorcycle myself.
We got it.
Yeah.